Now we can also work these problems backwards, meaning that we can start with a solution and work our way back to discover what is the function that that solution came from. And one of the ways we can help do this is I'm going to introduce to you what the linear factorization theorem is. So let's do this by example. I want to find a fourth degree function, fourth degree polynomial function with real coefficients. I know it has zeros at -2, 2, and 1. And I also know that if I evaluate it at 3, f of 3 produces a result of -150. So there's enough information to determine the function that this came from. So we're going to use a linear factorization theorem that says I can take any function and express it as a product of factors. So notice I have some leading coefficient times one factor, another factor, a third factor, as many factors as I need, linear factors as I need to have them all taken care of. Since this initial problem is a fourth degree factor or fourth degree polynomial, how many linear factors do you think are going to be in my function that I can build? There's going to be 4. Okay, how do I build those 4? Well, notice that 3 are already given to me. So how do I create this -2 as a factor? Well, that's an x plus a 2. How do I create this other 2 as a factor? That's an x minus a 2. This I, how do I create the I as a factor? That's an x plus an I. Oops, sorry, x minus an I. And how do I create the other factor? There isn't one. So, oh, that's right. Remember, zeros come in conjugate pairs. So that also means, doesn't it, that there's another factor right here of a -I. And so how does that factor? That factors to an x plus an I. See if I can make that a negative that we had before. So there are my 4 factors that I was able to obtain by looking at the given information. And then using the linear factorization theorem says, well, we can create a function, some f of x, will equal this with some leading coefficient with all the linear factors. So let's go ahead and start to see what we get here. X plus 2 times x minus 2, that's a difference of 2 squares. So I know I'm going to get an x squared minus a 1 out of that. Likewise, that's a difference of 2 squares. X minus I plus x plus I gives me an x squared plus a 1. I can multiply both of those together. Yeah, sorry, there's x squared plus a 4 right there, isn't there? 2 and a 2. I was jumping ahead. X squared minus a 4, x squared plus a 1. And so x squared times x squared gives me a, what is that? X to the 4th. Last, I have an x squared plus a -4x squared gives me a -3x squared. And last term times last term gives me a -4. All right, I took all the factors and multiplied them all that I could. Now I have this coefficient to deal with. So how do we deal with that? There's one more piece of information that I was given. F of 3 equals -150. So my function at 3, which is this function evaluated, which is an a times 3 to the 4th minus 3 times 4 squared. Oh, sorry, 3 times 3 squared minus a 4. That equals 150. Uh, 3 to the 4th is an 81 minus a 27 minus a 4 equals 150. One step at a time because I'm going to make a mistake if I don't. 81 minus 27 plus a 4, 31, 50. Solving this for A. Solving this for A gives me A, that coefficient equals 150 divided by 50, which equals a 3. What do I do with that now? That was my coefficient that I had in this building process. So my function now would look like f of x equals 3 times x to the fourth minus 3x squared minus a 4. And then cleaning it up, distribute that 3 all the way through. F of x equals 3 x to the fourth minus 9x squared minus 12. So there is the function that meets my initial criteria that has zeros at -2, 2i, and -i. And also produce a result that f of 3 is evaluated at -150. So we can work our way backwards. Oops, mistake alert. I know you guys caught it. I didn't. Again, I wrote this part down wrong, didn't I? That's right. F of 3 equals -150. So let's just, this was an easy one to correct. So -150, -150, -150, -150, -150 divided by 50 makes it a -3. So my solution then would have been a -3. And then I work my way through. This becomes a -3 plus and a plus. Sorry about that.